Hello, I am Bhargav Dembasya, and today I'll be presenting my group's Lab 6, which is data wrangling. So let me just share my screen really quickly. Uh, yes, so just going over it really quickly. What we have done over here is I have the data right here, PDFs, and then what we have is I have main two scripts. One is the OCR and extract, and excuse me, sorry. And second is the script delete, but the parseutils.py is the one that supports OCR extract. So basically, what we're doing over here is very soft matching in terms of the APIs, latitudes, longitudes, and everything. Like all the extra fields that the assignment mentions. Basically, what happened was first when I started doing the assignment, the problem was that we weren't able to scrape any information because firstly I assumed that it is OCR all over, so I used to pass 8 pages parallelly into the tesseract OCR and then extract details from there, but there was also text in it. So now what I do is I try it with text first and then fall back to OCR. This is under OCR and extract.py. Parseutils is basically just the it's basically just regex comparison. That means like string comparisons of what could be possibly the extracted API number or well number or the pressure, etc., etc. And also before that, we created tables. So I'll just show you. This is the script that we used to create the tables, but this is the initial commit. So it did not have like all like it was not a very well planned database. Because we then read again and we were like we have to extract in more information, and we were able to. So these are all the alter commands that I've used to alter the databases from time and now. Apart from that, yes, in the OCR extract, what we basically do is first we try scanning via text. Then, if it is not there, we fall back onto OCR. And on OCR, this has a batch size of 12, which means 12 pages concurrently. But the PC that we tested on, which doesn't have a webcam, so I'm not using it for recording, that had a batch size of 30, as you could see right here. So we parallelly process 30 pages using OCR, tesseract OCR, and then whatever we could extract, we extract and we fill in the fields. And then I've just added in a QC check, basically which denotes that if QC check's valid, we have both the API and the coordinates. But if even if like we have both the coordinates and the metadata. If it is invalid, this logic is right here. So yeah, latitude, longitude. If you have the coordinates, needs review. If the coordinates are not valid, that needs review. And if there is no well name, or it's less than 3, because of course there was a big name like a well name, so this is just like a fallback if we are predicting it wrong. Return needs review. Everything other than else is valid. So when we have both well name and coordinates, and we have the API number, of course API is used as a primary key, so we'll use it to insert wells as well. And I also added a fallback option of checking if the API is getting duplicated or not. In which sense, I would just replace it with the newest information. Uh, but that didn't happen though, because I had a flag, and that is it. And then basically what it does is just inserts in the file names. So if you wanna, sorry, yeah, that was just this is how it works. Yeah, because it is already processed. And then for the scraping, what we did is It was really simple. Created a Firefox agent, searched in for the API field, clicked on source database. The agent would do that, and it would wait because it would refresh to a newer page, and then they would have the table wrapper, and then under that they would have the results. I just fetch that as a JSON text in the console, print it directly onto the terminal. I have a script lined up already. This is the scrape drill edge script, and this is what I just mentioned. And also I was getting driver options. I'm installing the latest Firefox driver version, which matches my installed browser version because I had version mismatches. But yep, that is it. And then basically it just waits for a prolonged time because sometimes the website does take time. This is for one API ID and oh sorry, yeah. Um, yeah. So this is for one API ID and oh sorry, there's an error. Basically, I refreshed the virtual. I created a new virtual environment, but otherwise it would just return the ID as you could see right here. When I first ran Python scrape, and it would return me the API ID, the extra information from the API that I entered. I mean the script entered. So that is it. And lastly, we have the meeting notes, and we also have apart from that we also have the website, which is the second part. uh, yes, which is the second part. The website, I'll just show you really quickly. Just give me a moment. I forgot to fetch in the git repo, but anyways, yeah. So this was actually done by my teammate Harsh, but because he has an exam, so he isn't in the video. Um, yeah. So just really quickly, I don't think I have the. Oh yeah. Basically, what it does is it launches a map, and we have used the classic Google Chart pins to pinpoint where we have the valid wells, and we also have used tooltips from d3.js. And what it does, it basically is it basically when you like hover onto the icon, so that's the area of the tooltip. It basically we render the metadata and the information for that. So hopefully it works. And that is basically it in our project, our implementation for Lab 6. Thank you very much. Just wait. I'll just wait for this to open. Oh yeah. And I hope you could see the visualizations. So yeah, this is a pin, and if you hover onto it, if you click onto it, sorry, it opens up as a tooltip, and you'll see other pins as well over here. Not sure why not rendering, but yeah, this is how we. Oh yeah, there are multiple pins over here. Sorry, my bad. But yeah, you could click on like different pins and then view different information. That is it. Thank you very much. That was our implementation. Thank you.